He will bring it back. Gray will make him bring it back. All right, give me questions about your homework sheet. Oh, yeah, we did do most of them. 13. It's okay. I've got the integral of negative. So did the answers on the back help? Sometimes I think answers help more than solutions because when you have solutions, you're tempted just to like look at them and say, "This is how you do it." But with the answers, you can just check your work and then, Yes. So thank you. She's not sick yet though, but that's okay. Put it in the basket. Put it in the basket. That's good. All right, I'm gonna let you be 2x squared minus 3, and I'm gonna let du be 4x dx. So I'm really looking at the du here. So I've got the negative 16 and the dx. So how do I make negative 16 become 4? Divided by negative 4. So if I do divide by negative 4, then I counter out here with a negative 4. A big one though. What? My favorite what? I thought that's what you said. I couldn't even tell you a brand of whiskey. I couldn't. I was going, surely that's not what he means. Secant u, tangent u, and du. Okay, what's the antiderivative of secant u, tangent u? Secant. So I have negative 4. Secant u plus c, and then my u is, of course, 2x, 2x squared minus. Yes, no, maybe so? Yes, sir. Yes, sir. It's easy. Okay, let's do definite. Why is it what? Because I needed it to be positive 4x and it started out negative. So I had to multiply by negative to make it positive. All right, let's definite these things. Oh, I saw something this morning. Y'all are always asking negative cosine. Sine. Cosine. What? Real. Negative cosine. Definite integrals with u substitution. Have you paid this periodically, or you paid it all at one time?
I give it every.
But you've paid it as you go. You've never asked Freeman about it at all? All right.
I don't know. Didn't know about it. You had to talk to me. Yeah, why can't she access her account? And they were like, she hasn't done anything. Yeah, and it happened to add and it happened.
I agree. It's weird. Okay. Yes, yes, yes. It is, but in this case, we're going to let it be our u. It's not going to help me to factor it out. Good. What would du be? Okay, so tell me what. Okay, so I'm multiplying a 2 up here, which means I need to counter with a 1/2 out here. Yes? Now, this one's different because I've got to plug in, but I got to be careful whenever I plug in. So let's finish working our way through. I've got 1/2 times the integral from 0 to 1 of du over u. Agree or disagree? Slade thinks this is magic every time we do it. Okay, this is his
2 times a half equals x. Well, 2x times a half is more than x.
What's something else? No. Oh, because it was 16, I had to make it be 4. To make it be 4, I had to divide by 4. Here, there's not a number there, so to make it be 2, I had to multiply by 2. And then I always do the opposite on the outside. So over here, it was 16, but I needed it to be 4. To make that be 4, I had to divide by 4. Opposite goes on the outside. Because a 4th times 4 is 1. Yes. So over here, it had nothing. I needed it to be 2, so I multiplied by 2. I countered that with a 1/2 outside. So it depends on what you have inside as to what you put outside. Bottom. Oh, du, yes, du's on top. Du's on top. Okay. Yes, we could write it as u to the -1. What? No, you're not crazy. You're not crazy. Okay. But here's what I'm going to do first. And when you do this it's completely and totally up to you. I always do it initially because I'm scared I'm going to forget. These bounds, this one and this one, are not in terms of u. They are in terms of x. Okay? So you have 2 options. Option 1 is what I think is the easiest. I think the easiest thing is to plug in here and say u equals 1 squared minus 4, which is -3. Change this bound to -3. This bound, u is 0 squared minus 4, which is -4. And those are my new bounds, okay? So option 1 is adjust the bounds, okay? And whenever I take the antiderivative, so this would be log of u. And actually, remember we said it's absolute value of u. I'm going to evaluate from -4 to 3. That's option 1. Because if I'm going to evaluate with u, then my bounds have to be in terms of u. Okay, that's your other option. That's your option 2. Your option 2 is I can say 1/2 times the log of, and instead of putting u, I plug back in what I subbed, which was x squared minus 4. But I don't adjust the bounds. So what were they? 0 to 1. I prefer doing it the first way, but you can do it whichever way you want. Doesn't matter. At some point, you have to account, though, that your bounds are in terms of x and your u is there. If you go through and plug in the u, you can leave the bounds as they were. It doesn't matter. What's what? Okay, so the second one we did, you know how yesterday we were saying once you find the antiderivative, then you sub u out. You replace this back with what you started. If you do that, then you can just plug the upper bound minus lower bound and you're done. If you want to leave the u in, because it's usually a little cleaner to do that, you can adjust each individual bound in terms of u and evaluate that way. Yeah. Yes. Okay, so this one, let me show you. So this one would be 1/2. I'm going to do this in a bracket here. The log of absolute value of 3 is 3 minus the log of 4. Now, log properties, tell me if I subtract, how do I condense that? This would be a non-calculator. Divide. The log of 3/4. Okay, so option 2 is replace the u, write it back in terms of x. So whatever you, like up here, I had u equals x squared minus 4. I took the u out. So if you take the u out, you don't have to adjust the bound. If you leave the u in, you have to adjust the bound. One of the two has to be adjusted, either the bounds or the u. It's up to you which one. Oh, what? I think that's easy. You think which one's easier, the first one or second? I think the first one's easier too. If I come here and do the second one, I have the log of 1 squared minus 4 minus the log of 0 squared minus 4. Of course, this is absolute value. So I have 1/2 times the log of, shocker, this is 3, this is 4. Well, yes and no. It's my step that I did here came into play up here whenever I adjusted the bound. So it's there, it's just in a different place. Let's do another. Yes, we're definite integrals today. Yep. He's hunting in Mexico. We don't have to see him all week.
No, he's sick.
Yeah, he's sick. You know what's crazy though? Like, if he gets sick day or something.
But the way it goes now, your first 5, it doesn't matter if they're excused or not.
Yeah, but I'm saying like,
He knows a guy.
When I was sick, and then homecoming weekend, I had to go home,
exactly.
and then I was sick for a day. My doctor offered me. But
Well, good for you for being on there. Yes. Yes, yes, yes. Let's do. Should we do trig or should we keep it easy for a second? All right. Evaluate. Sure, I'll make sure and tell the AP people to quit using T because you will like T.
Yeah.
T represents time, so she used a lot. Make it look different. Do a little tail on it.
What? A little tail on it.
Yeah. So you can tell it apart from your plus. I bet y'all were the same people that whenever you heard first that there were X's whenever you were in pre-algebra. Who put this in here? Just use numbers like a normal person. And now you're in calculus saying just use X's like a normal person. How did you ever think it was right? That's why I struggled teaching lower level though, is because I struggle. Yeah. What was your question? I'm sorry. Yeah.
I helped Sophie with one of her. It was that thing where it's like, it was those square root problems where it's like you have to find a perfect square and then it's like
Complete the square.
whatever. And she was an Alex topic from Miss Lopez. She was and I was like, if I can do this, I'm gonna shut up about it.
Ah. Slade, what'd you put inside? What'd you put outside? Yay, what'd you put outside? Look at that magic you're doing. All right, literally magic. You need a calculator, as I said. 1/3 the integral from 0 to 3. The square root of u du. That's what I have. Exactly. That's why I did that. I mean, we're gonna change them. That's right. Well, if you do the second way, you probably do need a calculator. If you do my way, you probably don't, because this is 9. That's a perfect square. This is 1. That's a perfect square. Nah. What's the antiderivative? So yeah, no, that's right. 2/3. You 2/3 u to the 3/2, and I'm evaluating from 1 to 9. No plus c needed here. Yes. Okay. 2/9 times 9 to the 3/2 minus 1 to the 3/2. 9 to the 3/2. Okay. That's your challenge. What? Yes, I put those together. Why? Multiplication. What you're gonna do, it's 2/3. I just factored it out before I subtracted. I should do it all at one time. Factor. Fun.
Kenzie allows you to continue.
Okay, but look, if y'all think back, y'all have just forgotten rational exponents. This is take the root and raise it to this power. What's the square root of 9? 3 to the 3rd minus 1 to the 3rd, which is 3 times 3 is 9, times 3 is 27. $52 over 9. What 2? Yes. All right, the 3 over, what 3 over 2? Okay, sunshine. Think sunshine. 9 to the 3/2 is the square root of 9 to the 3rd power. Y'all remember that? Whichever one you want, but it's easier for me to take the square root of 9 and cube it than it is to do the square root of 729. Okay. Don't say that so ugly. What? Why what? We did. She asked where it went, and I was just telling her that I changed it to the square root of 9 to the 3rd power, which is 3 to the 3rd. I'll do a few more. Remember, the denominator of any rational exponent is the root that you are looking for, right? So what this is really asking is the square root of 9 and then raise that to the 3rd power. Well, the square root of 9 is 3, and 3 to the 3rd power is 27. So that's where the 27 came from. 1, 2, that it doesn't matter the exponent, it's just going to be 1. We'll do some. We'll do some together. I think they were saying it like, oh, that's it, not like that's all of it. Like, oh, that's the homework assignment. That's it. No, it's not.